Right now, scattered across our galaxy, there are stars that should be dead. They're ancient, billions of years old, and yet they're burning hotter, shining brighter, and looking younger than stars born just yesterday. That's not how stars work. Stars don't get younger. Nothing gets younger, but these do, because they've found a way to steal time. Not metaphorically, literally. They drain hydrogen, the lifeblood of any star, directly from a companion right next to them. The victim weakens, the thief thrives. Astronomers call them vampire stars, and there are hundreds of them, hiding in plain sight. Around 85% of stars in the universe are part of multi-star systems, pairs, or even larger groups. Our Sun, being alone, is actually in the minority. These stars orbit a common center, locked together by gravity. That sounds stable, but stability depends on distance. Too far, and the system weakens. Too close, and things get complicated. One of the most common vampire systems starts with a dead star. When a star, like our Sun, reaches the end of its life, it leaves behind a dense core called a white dwarf. It's basically a stellar corpse, but with extremely strong gravity. If a companion star is nearby, the white dwarf begins pulling gas from it, slowly, constantly. Now here's where it starts to feel familiar. It doesn't kill instantly, it feeds over time. The more it feeds, the stronger it becomes. Meanwhile, the other star gets weaker, thinner, drained. So you have something that looks dead surviving by taking material from something still alive. At this point, calling it anything else would feel wrong. And this is where the term vampire star comes from. As the white dwarf keeps feeding, it gains more and more mass. Therefore, it becomes increasingly unstable. Once it approaches about 1.4 times the mass of our Sun, a limit known as the Chandrasekhar Limit, it can no longer hold itself together. And then, it explodes. This is called a Type 1a supernova. In most cases, it destroys the white dwarf, but it often takes the companion star with it. So the system ends with nothing left, which is a very extreme way of saying that situation got out of control. But not all vampire stars feed this slowly. In dense regions of the galaxy, stars are packed much closer together, and when they get too close, they don't just pull material from each other, they collide. If one star is more massive, it can completely absorb the other, and as it consumes its companion, it becomes bigger, hotter, and brighter. It looks younger, but that's misleading, because massive stars burn through their fuel much faster. Therefore, by feeding and growing stronger, it's actually shortening its own lifespan. So technically, it benefits, just not for very long. And recently, a group of Indian astronomers found direct evidence of this process. Stars carry chemical fingerprints. When you analyze their light, you can detect specific elements, like a barcode. One star, called WOCS 9000, showed unusually high levels of heavy elements, like barium and yttrium, elements it shouldn't be able to produce on its own. Therefore, the conclusion was clear. It didn't make those elements. It absorbed them. Observations from India's Astrosat satellite confirmed it. This star had consumed material from a companion. The companion is gone, but its chemical signature is still there. And sometimes, this process isn't even just between two stars. A study using data from the Gaia Space Telescope found that about 40% of these vampiric systems are actually trinary systems, 3 stars interacting. That's a surprisingly high percentage. Therefore, it suggests the third star isn't just there by chance. Its gravity can disturb the system, pushing one star closer to another, which can trigger the feeding process. So, in many cases, this isn't random. It's the result of a complex gravitational setup. These systems aren't driven by intention. There's no plan, no strategy, just gravity and physics. But the outcome is consistent. One star survives by taking from another. And sometimes that survival leads to destruction anyway, because in the universe, getting stronger doesn't always mean lasting longer.